Spanish.
Hello.
Hey, how are you?
Good. How are you?
Doing well. Dun, 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 dun. All right, perfect. Cool. Have a good Easter.
I did. Did you?
Yeah, it was all right. Didn't do anything, so that was
Hey,
awesome.
that's kind of nice.
I
Us over here, we go a little crazy for the holidays.
got
My
you.
mom's side. So,
Gotcha. Okay, that's cool. All right, this week we are talking about plumbing and HVAC. So we will run through this and see what we have. Change that to that. Okay, perfect. Um, okay, so looks like we're going to start with HVAC first and then move into plumbing and then talk about coordination and then some change order stuff. So again, need to work on getting these videos up done correctly. But so anytime anybody mentions mechanical, that can be plumbing or HVAC. Most of the time, it's HVAC though. But if you have a mechanical company, a lot of times they will perform plumbing and HVAC. If they are just doing plumbing, then they typically are not a mechanical. They like won't be ABC mechanical. They'll be ABC plumbing. Just as a little caveat.
okay.
All right, so HVAC systems. So kind of what we look at is whether it's a split system, whether you've got an RTU package, if you've got an air handler, and then of course exhaust and ventilation. Those are always big. So split system, separate indoor and outdoor units, refrigerant lines connect to them. So you're going to see that in Dalton. You're not going to see it on the plans though, but you will see it actually in place. Condensate drain from your air handler, common in retail and office. So refrigerant line routing, condensate drain slope. So a common scope gap is going to be who runs the condensate drain. So typically that's the plumber. But the plumbers will exclude it sometimes. Or they will tell you, nope, I didn't pick that up. Sorry. That is always something to clarify on your scopes. The reason that the HVAC guys never pick it up is because it's PVC and it typically ties into a drain. So they will tell you, nope, we don't have the condensates. Um, Talking about refrigerant lines, so when running a split system, so that's going to be like your mini splits. So for instance, so they're the single units. There's no ductwork, and so their refrigerant lines are literally run from the unit, which is the head unit, which is inside the office, so like in the Smitties, and it's run outdoors to the condensate unit or the condensing unit. And the condensing unit is what actually powers the uh, the unit itself. But so you can kind of think of those as just like one-offs, like independent little mini splits. Like in Dalton, what you're going to have are rooftop units. So those are RTUs. That's what RTU stands for, is rooftop unit. So those are the big units that you see sitting outside. The split system is also for like like in a house, where you've got a condensing unit on the outside of the house, you've also got, it's very much like it's very similar to a mini split, except you run your condenser to the air handling unit, which is going to be on the inside of the house. And that's what your ductwork would actually tie to. So I guess it's not really similar. Yeah, it's not really similar. I shouldn't have said that. But because you do have ductwork. The big thing with the mini split system is you have no ductwork. So
Okay.
wherever that, and you have one supply. So that wherever that head unit is inside the office, that's it. That's all you got. That's all you're going to get. Nothing else. Where an RTU with a condensing unit on the inside, and then let's look at a couple of examples. So when I think RTU, I think like Walmart.
Okay.
Um, let's see if we get a decent. Let's go to images. I was hoping to find one on the inside. So Walmart, there is ductwork. Sometimes but the RTU unit actually penetrates the roof. Like you can go into a Walmart store and look up, and you can see where all the ductworks run. You see where the RTU unit's mounted. But in some scenarios, these will actually penetrate the roof deck, and there won't be any ductwork. It just blows into the open space. All right. Um, on these particular units most of the time. So like what you're seeing here is a condensate. So that's going to be a condensate drain. It may not be a condensate because it's run kind of funky. Nope, it does say it's a condensate. Okay. So, but the condensate drains are run on top of the roof.
Okay.
And then they typically tie into one spot. Something when you're running HVAC on a roof or running anything on the roof, you got to make sure it doesn't sit on the roof itself. So like there's either a stanchion that is used. They make them specifically for gas lines, for PVC pipe, for duct work, whatever, but it elevates it up off the roof surface.
Okay.
You never ever run anything on the roof. Actually touching the roof. And the whole reason you don't do that is because if it's run on the roof, like there's got to be some way to secure it. And you don't want to secure it through, your roof membrane. So, um, so air handling units. So this would be a big one. So that would be a massive one that's on the inside of a probably a university or something. Sometimes these air handling units are part of the roof, are part of the RTU. So one side of it's going to be, the part that the part that circulates the air and runs the air down into the cavity, and then the second part is going to be, the what actually regulates it. But by and large, most of the time, what happens is these even when we have a small rooftop unit, um, it's run to one of these, which would be
Okay.
like you'd find in your house, or
Okay.
your apartment. There'll be a cabinet that this runs to, and this actually controls the heat. It controls the AC, as long as they're on the same system. Bigger buildings, they do make two completely separate systems for that. Have a boiler and have a or heaters. Like in our car washes, the radiant heaters and the heaters that are in the equipment room are completely independent of anything else, and they don't put off any AC. They are only for the heat.
Okay.
All right. Um, let's look at so that would be an air handling unit. Um, Actually, not boiler. I said boiler a while ago. I should have said furnace. That's what I meant to say was furnace. Um, all of these are very common to what you'll see in your house, of course, or in your apartment complex. There, that one's going to be a little bit different. So that one probably, I can't tell. That may handle both. That may be a furnace and an AC unit. But just know that it could be different. It could be a combo unit. Whatever it says on your spec page is what's going to, or what in your submittals is what's going to tell you, where you've got it. So, um, let me see, what was the other air handling unit? Oh, exhaust and ventilation. Okay, dedicated exhaust fans, toilet, kitchen, chemical exhaust. So anytime you have a bathroom, you're going to have exhaust fans. Call them fart fans. Anytime you have kitchen, anything in the kitchen, you're going to have to get that exhaust out of there. And a lot of times that's done in the form of an induction hood. So you would have So like, again, in your kitchen, in your apartment, you've got a hood, I'm sure, and you've got a fan that you can turn on that's meant to, so when you're cooking something on the stove, it's meant to suck
Hmm.
that air or that grease as well. It'll also suck the grease up. That's why in your commercial kitchens, which I don't think we have one in Dalton. It's not really they don't really have a commercial kitchen in that grocery store, so,
Hmm.
or that convenience store, um, but you have let's look up kitchen hood. So a lot of it in the fancier houses, you're going to see something like this.
Hmm.
That's going to be like over an island or something. But in our world, it's going to be more of these. This is going to be what you're going to see,
Yes. Okay.
which, yeah, which you've seen it. These are filters, and they also have, of course, the lights have these globes on them. They have that because they have to be shatterproof. And you'll have what's called an Ansel system, which is your fire system. So anytime it detects heat at a certain temperature, it will disperse chemical and make a real big
Mhm.
mess and hopefully put the fire out.
Okay.
But these will be mandatory in wherever we're working if they have anything really close to a commercial kitchen at all.
Okay.
Um,
That reminds me of the second location in Billings. That was the restaurant, and we were selling all of the equipment and everything out of
yep,
there. I saw a lot of those. So that,
absolutely. Yep, 100%. 100%. Let me see if there is anything else we need to know. And your drawings will tell you the thing you'll just have to remember is that they are very particular on the spacing for the
okay.
units and on the hood. So you cannot have anything protruding outside of that hood. So if this griddle here is supposed to be covered underneath and it happens to be 3 or 4 inches on the outside, you'll fail every time.
Okay.
Just as an FYI, um, just stuff to watch out for. Kitchens are a whole different ball game because nobody ever typically reviews see, we're probably going to have that problem on Dalton, even though it's not a commercial kitchen.
Hmm.
That's why we tried to get all the cut sheets to begin with, because a lot of times well, we don't even really have electrical drawings, but a lot of times if we had electrical drawings, the voltages that were called out for the individual pieces of equipment will be different sometimes. So we've got to try to head that off in the submittal process so that we don't pipe it and plumb it and run electrical for a 110 circuit, but the equipment comes in and it's got a big 220 plug on it and we got nowhere to plug it in. Now we got to repull wire, we got to change the plugs out, we got to do a change order. And while it's probably not our fault, the owner's going to come to us and say, "Well, I gave you all the information. I don't understand why y'all couldn't coordinate that better." You're like, "Well, that's, not really our job, but that's what we do." So, let's see. Exhaust fans. Let's look at an exhaust fan. Believe it or not, I did not know for the longest time what an exhaust fan looked like on top of a roof. But these will also sit on a curb. You'll have an exhaust curb. They're just much smaller.
Hmm.
So on a like you'll see the turbines, residential. So
Okay.
that'll suck heat and some are motorized, some are not, but that'll suck heat out of your attic space. These, as you've seen, are louvers that'll go on the. Sometimes they'll have a fan as well, and these are like the ones we used on the car wash. We had one on the second floor, and then had one on the bottom floor in the corner of the equipment room. But its sole purpose of those is to be able to suck the heat out of there and try to keep it manageable. But this is what that's a commercial exhaust fan. You can see it
Okay.
sitting on the curb. That's exactly what an exhaust fan looks like. Everyone looks almost the same. They may have some different housing on them, but they will all be, unless you get into the huge ones, but the ones that are much, much bigger. But that's pretty much exactly what anything that you see that looks like a mushroom cap or looks like a big mixing bowl.
Hmm.
That's going to be your exhaust fan.
Okay.
Right. Whoops. Let's go to, here we go. All right. So HVA sequence and installation and PM hold points. Okay, so really, that's why in our phasing schedule of buyout, phase one, phase two, HVAC will typically fall in at the end of phase two
Okay.
because it's going to be at the tail end of the top 10 critical trades. Because almost all of their stuff is above ground. So what am I trying to say? Any of your priorities will be to start from below the ground and in the ground and build your way up. So underground rough end condensate drains again, and floor drains and gas. Yeah, you need to have the HVAC contractor involved with that, but all that's going to be run by the plumber. Every bit of it.
Okay.
They put in the floor drains. They'll install the gas that's underground, and they'll install the gas that's overhead. But all of that is done by the plumber. But the plumber is going to say, okay, I got the condensate drains, but where do you want them? Where do they need to go? And then so then above slab, you've got drain lines, gas stub ups, and sleeve placements. So let's think about drain lines going to be your condensate drains. So that's kind of just where they're going to be run overhead. Typically, they're in a wall until they get to the attic space. The gas stub outs, pretty simple. All the HVAC contractor, if you've got gas on a job, all he is going to do is connect. He would typically make the final connection from that gas but he's not going to run the pipe. He's not going to hang the pipe if it needs to be hung. He's not going to paint the pipe. He's not going to do any of that. Sleeve placements. So that's if we've got really for an HVAC contractor, sleeve placements would be if you, for whatever reason, needed to run, you didn't have a whole lot of attic space and you needed to run through a firewall or something like that, then you would probably sleeve that firewall if your duct were not already installed. So I don't really think it's honestly, these first two line items are not necessarily applicable to an HVAC subcontractor other than actually getting their input. That's it.
Okay.
So then your concrete pads, so that's going to be another word. So anytime that we have a piece of equipment, it needs to sit on what's called a housekeeping pad. So a housekeeping pad is going to be either so like on our car washes, the mini splits, the condenser that sat outside, sometimes they sat on a pad of concrete. Sometimes they will sit on a rack and the rack actually bolts to the concrete if it's on a sidewalk. In the back room, we didn't have any housekeeping pads in our car washes, but you will commonly see a housekeeping pad for your transformers, our transformer was on the second floor. You will see housekeeping pads for maybe hot water heaters, something like that. If they're sitting on the ground, a lot of times the little hot water heaters now are either Insta-Hots, which means they're right underneath the sink, or it doesn't have like a traditional tank that it sits in. Let's look at. But the purpose of a housekeeping pad is to obviously elevate it off the floor, so that imagine if you had a transformer sitting on the floor and it flooded. Then water is going to get inside that transformer. Let's go to equipment. Let's see if we can find a good example here. They make them all. I mean, back in the day, you would always pour these. But you can see that they make precast. There's a good example. So that would be a housekeeping pad that a transformer is sitting on, and it's on legs. So now that thing has to flood all the way to here before it actually affects that transformer.
Okay. Yeah, I found a good example for a hot water heater. I did housekeeping pad, hot water heater. And I've seen that before. That's typically I feel like that you would either have that in your backyard or at the wash or yeah, stuff like
Yes.
that.
Yeah.
Mm-hmm.
So this will actually be a transformer pad,
Mm-hmm.
but it serves the exact same purpose. It's to elevate the piece of equipment. That's whether it's a
Mm-hmm.
transformer pad, housekeeping, whatever, it's to elevate the piece of equipment and give it a level place to sit. That's what
Okay.
you need to, that's basically what you need to think about. But the scope gap is they're very seldom are they called out on any of our
Okay.
projects. So that typically ends up being an ad because the concrete guy's never going to pick them up unless they're called out because he's not going to pay any attention to what equipment is going where. So,
And so is that something that you could avoid as a PM by reviewing the plans and seeing that there's a
mhm,
transformer out there in the yard? You're automatically going to know we need a
100%.
housekeeping pad for that. Okay.
100%. Yes. Same thing with like a condensing unit. If you see a, on the Smitty's drawings that we started with, they didn't have a sidewalk or anything outside where, and they didn't even show where to put the condensing unit on some of the drawings. Ideally, so like on a mini split system, you want the head to be on one side of the wall and you want the condenser to be on the other. And the reason you want that is because it's the path of least resistance, right? You're going right out, going right down, maybe through the wall, but you're in this wall. Where
Mm-hmm.
if you've got the head mounted over here, now you have to run the lines through the attic space and out and down and maybe across the stairway or underneath the stairwell, whatever. Sometimes it's unavoidable, but always you want to try to put them on the same wall if you can. But yeah, they didn't even show a housekeeping pad or anything on the drawing. So we
Mm-hmm.
just had to come up with that. Like, somebody said, well, where the condenser goes right here, what are we setting it on? Well, we can't set it in the landscaping. So we need to pour a pad. So
Mm-hmm.
not a
Okay.
huge dollar amount, not a huge
Mm-hmm.
dollar amount, but it's something that's always missed typically.
Mm-hmm.
Let's see here. Let's see, roof curb sets. Let's see, verified dimensions match equipment submittals. That's fair. So if we do have a housekeeping pad that is called out, you'll just want to look at so you want to look at the condensing unit or the RT or whatever a piece of equipment, doesn't have to be a condensing unit, and make sure the pad's big enough. That's it.
Mm-hmm.
That's all you're kind of looking at. And you can kind of cut that off, you can go ahead and send in an RFI and, we can expand it and all that kind of good stuff.
Okay.
Ductwork and distribution. So this is going to be a big deal especially like in Dalton. Um, let's look at a drawing because we actually had several calls. Trenching plan. We had several calls about the HVAC. Oh, that's just a snippet. All right, so this is something that we had to work out on the HVAC. So our original drawings, we're going to spend a few minutes on this because it's important. Um, there we go. So this is going to be the lower, yeah, that's the upper. So this is the lower framing plan. So this is how it was framed. And without us having mechanical drawings or anything, we got to looking at this and we were like, holy shit, like, how are we going to run ductwork in this? Like, how does this even make sense for us to be able to run ductwork? We
Mm-hmm.
have an attic space over here because that's a gabled roof. So like if you go to let's look at our elevations as well. That doesn't look right. Let me look here real quick. There we go. That's a good example. So our attic space is going to consist of the bottom of that bar joist to the roof deck. So we already know, looking at it previously, we got like 2 feet here. not very
Hmm.
much room at all. So this ductwork is going to come down from the RTU and it has to go somewhere, has to do something. So if we've got these bar joists running this direction every 2 feet, that's going to be a problem. Not as big of an issue. Not as big of an issue. Let me go back to here, because we have tons of attic space. Like we can run ductwork through here. So when you think about this, you got to think about the ductwork, whether it's round or square. But say that ductwork's running here, it's running that way. Okay. And then as it turns, so in between the joists, it would run like we would tie off and make, that's where this drawing comes in. So this was kind of showing how we intend on running the ductwork. So we're running it from this RTU right here.
Hmm.
And also the sizes. So we were actually able to size all of this down to where, so ductwork, think about it as so you're moving air, right? That's what you're moving. So if I'll draw something here. So if a duct, so say it calls for it to be 30 inches by 30 by 30, something like that. Okay. Well, you've only got a 24-inch space to run it in. So that's not going to work, right?
Hmm.
So you could go back to your HVAC contractor and say, okay, well, here's our problem. We've got trusses that have a very small space, and with your ductwork and your insulation, because they have to insulate the ductwork, so that adds like an extra 2 inches on each side. We're going to be at like, if it called for a 30 by 30, we're actually going to be at like 34 by 34. Okay, well, so then he should be able to look at that, and also it could also be done via RFI. Like if your HVAC contractor is not on board yet, hopefully this is something that they've already vetted and figured out, but a lot of times they don't. You could take that. So you want to move 30 inches by 30 inches of air. Okay, well, what's the equivalent to that? Then you could run it further this way and shorten it up if that were the problem. Sometimes it's okay to do, sometimes it's okay to do a round duct. So you could actually put a round duct in there and move the same amount of air. Round duct's probably not going to help you in this case because it was already 30 by 30. So your round duct would have to be bigger than that anyway. But you can always, so the important thing to remember is if you're 30 inches wide and you're 30 inches tall, just as an example, and you go to say we've got plenty of room in height. We got tons of room in the height, but we don't have very much room in the width. So then you could shorten this up to say 22 inches. And then, well, then how tall am I going to have to be in order to move that same amount of air?
Okay.
So
Hmm.
if you're 24, then maybe you're 4 foot tall, something like that. You do have that liberty in order to work with in order to change the ductwork and change the sizes.
Okay.
But we're going to have to make penetrations in our steel trusses in order for these to go not this direction but the other direction. So there's actually going to be holes, and we don't have, so like we're not going to, these are bar joists that you see here. We're doing I-beams.
Okay.
Let's look at, get this out of the way. Let's look at, did we do yeah, so these are our beams that we're using. And see, they're going to pre-make these with penetrations.
Okay.
So this is how the HVAC duct is going to be getting through there.
Gotcha.
But that's all stuff that literally took us probably 2 months to sort out because the HVAC contractor was very slow getting information back to us. But if you can do this, this is the ideal way to do it. But not only do you also have to get the blessing of the structural engineer. Anytime you cut anything that's structural, you have to get their blessing to make sure that it's okay. I was hoping that there was going to be like a layout because it's difficult to understand. Maybe this is it. Yeah. Okay. So those same beams, This would actually be the layout of how they go. That shows a roof deck. That's what that is. So our penetrations are, again, kind of difficult to see, but you got one there, you got one there, you got one here. So that's just an abbreviation for opening.
Okay, that's what I thought, but
So
just anywhere it says that.
Yep, and your HVAC unit will actually sit right here. That's why this reinforcement here. See, it says field fit. So they'll ship this angle, and wherever that angle needs to set, they'll actually weld it.
Okay.
But this is where your HVAC unit will fit. So you've got piping. That's where you kind of go back to this drawing. That's where it's setting. So you've got this big trunk line, and you can see it's only 20 inches wide, right? So that's to get in between the trusses. And then it's run this way, and then you've got them running back this way. Well, that's why you've got all these openings, because they're going to pass through here.
Gotcha. Okay.
All right.
And now how common is it on a lot of the jobs that you've seen that you guys have to make this plan?
So we should do it on a lot of them.
Okay.
Not real applicable to the car washes because we have a lot of open space. We don't necessarily have an attic space, other than maybe in the office. But no, these need to be, you need to go through and vet these anytime that we're building anything. So obviously if it's a TI that we're only doing an innovation or a renovation on the inside, not a big deal. But when we build it from the ground up, when you start to look at drawings and stuff, that's kind of what you're looking for, is your pathways in order to get stuff from one area to the next.
Okay.
Don't just leave it for the field to figure out. That's like, we don't ever want to do that. This is actually where the second RTU will sit, right here. And it's piping this direction. Let me see if that's on this markup. Yeah. So it's on this markup, but what it's doing is it's actually running, because your gabled roof starts like right here. So it's going to penetrate like right there. Let's take a look at our units. Thought there was another. Yeah, this is a good example here. Okay, so we know that all of this is gabled, right? So we have a bunch of attic space here. This is a note that we made because, and this is something that we caught, because they showed this ductwork coming over here and feeding that diffuser. Well, that's not going to work because this ceiling height is only like 9'10" right here. And this is coming in at below that. It's coming in at like 8 foot, something, or 9 foot, something like that. So we actually had to feed this diffuser from this side over here.
Okay.
So that's why we said eliminate this penetration, feed from existing building. So we're coming from here because that's the existing building, and we're penetrating inside there. Again, the end view is like right here. So that's where we're talking about. And you can see the difference. So if we were trying to feed something, if we were trying to feed ductwork here, well, all of a sudden we're in the sales floor now. Like your ceiling, your truss height is 12, but your actual ceiling height is going to be like right here. And I just know that from looking at the other drawings. So, and knowing my ceiling height. But so you would actually have exposed ductwork inside the sales floor, which is no bueno. So that's why we had to feed it from up here, and then it'll drop down. So,
okay.
All right. All right, equipment set, AHU, RTU, exhaust fans installed. So sometimes with big, like, how do we get those exhaust fans on the roof? How do we get those RTUs on the roof? So most of the time, it's going to be all the time. In fact, unless an exhaust fan, you could probably get up with a lull, depending on your ceiling height. But a big RTU unit or something like that, you're going to want to get up there with a crane. So you just need to make sure that that's included in your HVAC. And your estimator should have done that too. But you need to make sure that the crane or the means at which they intend on getting that equipment on the roof is actually, bought out.
Mm-hmm.
And then lastly is TAB, commissioning. Okay, so TAB stands for test and balance. So when you have a space like we'll have in Dalton, it needs to be, once they install all the equipment, in order to get it to run correctly, they will need to do what's called a test and balance. They will need to test and balance the system. Let me show you what, because that's actually kind of explain what, there we go. So what happens is the guys go around and they put this cone with this meter on it up against the actual flow. Either they do it on diffusers, so that would be like your depending on whether it's a supply or a return. So and then it calculates how much air it's actually putting through via the CFMs, and then they'll check their plans and say, okay, this room is supposed to have whatever the number is. And then they will go back to the air handling unit. And most of the time nowadays, it's done on bigger jobs. That's done via a program. They have like an energy management system that they'll program it. Or they will go and program their air handler to either put out more air or less air, or inside that diffuser is typically, and inside the ductwork is typically a damper. Okay. Now, a damper is a door on a door on your ductwork. So think about like in your house or in your apartment, you've got as long as the air is in the ceiling, as long as it's coming from the ceiling, you've got a vent up there, and you typically have like a little lever that you can move, and that's to shut that damper. So if you want to decrease the airflow, you move that damper. If you want to increase airflow, you move it back the opposite direction, and it pulls, it pours, air through there. But this is essentially what it is. All it is a door.
Okay.
All right. And sometimes they're done manually with, like talking about like your house with the lever, or they're done electronically and they automatically open or close, depending on airflow, depending on the system, depending on the time of day, blah, blah, blah. It can get really, really in the weeds on it. And sometimes they're one door. Sometimes they're more like the louver, that like you see at the car wash. That's a damper, also known as a damper. But those are going to be in at all of your diffusers. You should have dampers, because that's how they'll regulate the air and adjust it. Let me see if there's anything. Yeah. So, like I said, not a big deal. Just know that that's how they do their test and balance. So when you get a test and balance report, that pretty much says, okay, you need to allow time on the schedule, because on bigger jobs, they will, like, it's going to be a requirement for you to get your certificate of occupancy is that your test and balance report's done.
Okay.
But it's also important for the owner to have it done, because that is part of, if you're going to have, so especially if it's a public place, I think about hospitals or rehab places that I've done. If it's not tested and balanced properly, like people in the lobby may get hot, people in the kitchen may get cold, people in the cafeteria, whatever. So, and it's a contractor, typically it's a contractual requirement, but a lot of times the HVAC contractors will exclude it. And the reason they exclude it is because you typically, a lot like testing, like having a testing lab and a general contractor, you want to have the test and balance done by an independent third party that doesn't necessarily work for the HVAC subcontractor.
Okay.
Just for transparency.
Gotcha. Okay.
Yeah, it's not that you think they're going to do something dirty, but at least there's never any question, as far as, a test and balance report. Okay. All kinds of different ductwork. Rectangular and galvanized and round spiral is going to be your most common. You will see flex ducts run from a, let's see if we can just find some examples of all these. Ductwork. So obviously that's going to be circular. You can see the insulation that's on the outside there on that square duct. Um, this is all hard duct. This is all hard piped. Um, if you're looking for flex, can only be run for so far. Um, so a lot of times what they'll do is they'll tie on a piece of flex if they're not exactly sure. So the flex obviously allows you the ability to move your diffuser.
Mhm.
So like let's see if we've got a ceiling plan. For aesthetics, you always want your diffuser, you want your light fixtures, you want your sprinkler heads. If at all possible, you would like them in the center of a tile just because it looks a whole lot better.
Okay.
Here we go. Well, that's my tile. Shit. All right, let's pull one up. So it's going to be on what's called the reflected ceiling plan.
Oh yeah, page DD 4.1 for Dalton.
DD4. There we go. So you can see that. So that's and you'll also most of your ceilings. In fact, 99% of your ceilings that are going to be drop ceilings with the grid and the tiles are either going to be 2x2 or they're going to be 2x4.
Okay.
Okay. You build them the same way as far as the grid goes. The difference is you're going to have a piece of grid every 2 foot if it's 2x2 tile. But you
Okay.
can see how they've got these. I don't know if that's actually showing lights or what that's showing. I'm not sure what A is, other than maybe just a ceiling type. I don't know. Let's say that they're lights. That's
Okay.
just for shits and giggles. So when we go to put sprinkler in here, it just looks awful if number one, and it's going to throw your grid off because like we need to mark. So what I typically do is I'll have them mark on the ground where the diffusers go, where the light fixtures go, and where the sprinkler heads are going.
Okay.
That way, when they mark it on the ground, we can transpose that mark up, and we can see exactly where it's going to hit. All right, because ideally you want, whether it's a light fixture or whatever, you want it in the center of that tile if you can help it.
Okay.
Sometimes it's unavoidable. Sometimes you don't have a choice, right? But it just, like I said, it looks a whole lot better when we do that. Diffusers, you prefer that they match the drawings because they're going to be drawn. So if these were diffusers and not lights, you can see how they're all lined up here in the center of the room. The other reason that that's important is because if these are supplying air, then the calculations based on how it's supplying that room have been determined by where it's located in the room. So obviously, if you've got a diffuser that's supposed to be or supply air that's supposed to be here in the center, but it's for whatever reason, whatever god awful reason, they've put it over here, that's a problem.
Okay.
It's never gonna, there's got to be a reason behind that. Maybe we added a second one, or maybe we added something, but there's like, and you should know, if you walk into a job site and you see something like that and you don't know anything about it, that's another problem. Like somebody's not communicating. Um, Yeah, I don't see whether those two. I'd have to look at the lighting plan may not tell me anything either. No, there's not actually a lighting plan. Whew. Goodness, excuse me. Okay. But flex duct, so that's where I was getting with the flex duct. They've got a little bit of, so if your ductworks run above there, then they'll typically have a branch, and then they can attach some flex duct. So
Okay.
yeah, it's literally that. It's flexible duct
Okay.
is all it is. Um, that's hard piped. It looks like it might have a little bit of flex here, but it would help them be able to move this a little bit if they needed to as well. That's another pretty good example of that. They do the same thing with fire suppression. You can put fire suppression can either be hard piped or it can have like a flexible line on it. Typically, it's about a 6 foot line. So if they actually need to move over somewhere, they have the ability to do that and not affect. There again, it's important that they go really close to where they're drawn, because a fire suppression engineer has looked at that and said, we have code to meet that we have to match. We need to be in this area because we've got this much coverage. So if you move one, now we take the chance of not having coverage in wherever you moved it from. So same type of thinking, like with with lighting, same thing. They have something called foot candles that's how they measure light in a room. So the lights are spaced very particularly in order to provide the most amount of light to that room. So um, I'll reply to her in a minute. Okay, cool.
It's
So,
interesting seeing these and actually learning. Like, I've seen the duct work before, but I've never known the difference between them all. So it's interesting seeing all the photos and
yep,
the names and knowing their purpose behind each one.
absolutely. So they'll have insulated duct board. So think about like when we talked about the roof. Remember, we had a piece of sheet of insulation. They also provide that for like ducts when they're square. So sometimes it's easier, instead of having like wrapping it with like fabric type insulation, they'll actually do a rigid insulation. So, um, and then of course we'd already talked about exhaust hoods and the chemical exhaust and the fire rated. That's where your Ansel system comes in, and it'll put a fire out if needed. So. Let's see here. Ductwork inspection checklist. Hanger supports spaced. There is particular spacing on the hangers that they use. Ductwork gauge matches pressure class per. Okay, that's getting into the weeds. Let me read through these. Seam sealed. That's something that's easy to look at. So again, any insulation that you ever put on anything needs to be, if it overlaps, it needs to have like tape. Whether that's insulation board, whether that's ducts, whether it's got to have tape on it. Same thing with rigid. Rigid duct, instead of taping it though, they have what's called pookie. So they will take pookie and put it on the joint. So,
that is a funny name.
Yep. So
Oh
if
yeah,
we,
there it is. Gray Pookie.
yep, that's if you pookie the ductwork. So,
Okay.
yep. Flex duct, fully extended, no sags, max run of 5 feet. That's probably code. I'm sure it's right. It's going to just know that there's a max distance you can run it. Dampers we've talked about. Again, a lot of those are used for smoke and fire. So like if you're in a building that has fire alarm and everything, and a lot of times those dampers will be wired. Common scope gap as well is if they have electronic dampers, then who wires those? Because typically it's low voltage, and that's not going to be done by the electrician.
Okay.
So just a scope gap opportunity. But all that says, if the fire alarm goes off, if the fire alarm trips, those smoke dampers will shut. So if there's a fire in a room, it keeps the smoke from going out the ducts. It turns the system off. That way it doesn't suck the fire out. It's sucked in because it's not only sucking smoke though, right? It would suck the flames too. So,
Mm-hmm.
um, access doors. So access doors are very important on, it's something that we probably haven't given any thought to in Dalton. But it's going to be, and a lot of times, to be fair, it's not something that people really think about until the end. But remember, we talked about at some point, I don't remember when, but we talked about access doors for plumbing or stuff like that. But all it is essentially a way to get to
Mm-hmm.
your attic space or your something.
Yes. Yes.
So sometimes this is going to be a bigger job. There'll be access doors actually. So wherever you have a damper, like if you can't get to it from the outside, sometimes you need to have like a door on it.
Okay.
Just always, the deal is just always think, how are we getting to that if we close that wall up? That's
Mm-hmm.
it. That's really all
Okay.
you got to think about. But the most common thing is definitely like access for plumbing, trying to get to isolator or I forgot what they call them. It's on the tip of my tongue. Anyway, it keeps the vibration because when a line's under pressure, so like when you go to flush a urinal or you go to flush a
Mm-hmm.
whatever, they have what's called damn, they have what's called isolator valves. We may go over it actually in the plumbing section, but
Okay.
or like hammer arresters, but it keeps the vibration of that line when it's under that pressure will actually make noise. So
Okay.
that's they put like a something on it to keep it from doing that. But you got to be able to. It's got to be accessible. So that was kind of where I was going with that.
Okay.
And then TAB report reviewed before ceiling close in. A lot of times you won't necessarily have a sheetrock anyway. You won't necessarily have a TAB report done yet for that, but typically, a lot of times it's going to be in your drop ceilings anyway, which isn't a big deal to be able to access the attic space. So, all right. Any questions on HVAC that you've had?
Well, I guess not necessarily, but on like scope gaps, when things do get left out and, you know, at that point, would you contact the person that is responsible for it and say, just do a change order and have them pick it up, like for the fire and smoke dampers?
Yeah, that's really all you can do.
Okay.
You'll have to ask them for a quote on it, and then it's going to be very important that we actually get the breakdown on their labor rates, their actual material quantities, all that kind of good stuff, because they will, although our contract says that you can only make 10% on change orders, it's going to be like they're going to build some money into that.
Mm-hmm.
So you got to watch the productivity, you got to watch all that. So um, hopefully that would start with an RFI to the design team, and then that would facilitate the change order based on their answer.
Okay.
Because if it's not shown on the drawings, then it should be something we were able to get compensated for. So,
Okay. Okay.
okey-doke. All right. All right. Let's hop into plumbing. Let's talk about some plumbing. So, uh, obviously, things you'll see and hear all the time talk about a domestic water supply. So that's anytime you hear the word domestic water supply, that's local, your local water supply. So that's how you're getting water basically from the street, from wherever the city connection is, all the way into the building and coming out that faucet, essentially. Um, there is a different terminology for if you have so in the state of Texas, when you have fire suppression, you have the fire water has to be on a separate line than the domestic water. They can't be on the same line.
Okay.
And the reason they did that was because if whatever reason, your water's down. So if you have a water main break, like say down the block from you and your water's turned off, your fire loop water would still theoretically work as long as it was on a separate main.
Okay.
But just kind of keep that in. So in Massachusetts, it's not the same way. They can have the domestic and the fire all on the same line.
Okay.
So domestic water supply, cold water, service entry and well, hot water from your water heater or your boiler, distribution piping. So from where the water is coming in, how's it being distributed to the rest of the building? Okay. Is that via copper? Is it via CPVC? Is it via PEX? You know, how's that being distributed? The pressure at the fixtures is typically 4 to 8 psi. That's going to vary widely. And they will put like pressure reducing. Typically, if the pressure's coming in, there'll be some pressure regulators that'll keep that pressure down, because obviously if you let that water come in full bore and it's like 120 psi, it's going to destroy whatever your fixture is. It's going to tear it up. So PM flags, believe it or not, some plumbers will not quote insulation on their water supplies. But anytime that plumbing lines are in an exterior wall, they have to be insulated from the cold, even if you're in Texas, because the R value of that wall is typically not enough to insulate it by itself. And the insulation in the wall is not usually enough. So the line itself has to be, because there's nothing worse than having a frozen and then a busted water line inside a wall.
Mm-hmm.
Sucks. So,
and then
go ahead.
Sorry,
Mhm.
you say that the plumber won't take care of that, or they typically won't do it. So do you normally have to, that could be a scope gap?
Yes, 100%.
Okay.
Yep.
Okay.
Could be a scope gap. Some plumbers will do it. Some of them will call it out. Some of them will specifically exclude it.
Okay.
So it's just something to watch out for. I assumed when I was early on in my career that if it was your pipe and it needed to be insulated, then that's part of your scope. Not necessarily the case.
Gotcha.
So it's kind of the opposite of, but HVAC subcontractors, like when we talked about insulating their ductwork, I've never had an HVAC contractor that didn't pick up insulating ductwork. Like it's like part of the deal.
Okay.
So let's see, pressure test before you close in, and then fixture rough in heights. Okay, so that's important. So if you've got a sink, and you're not exactly sure where to put that sink, you got to make sure that it's roughed in the correct places. So that's where we also end up with change orders when a owner walks into a room and says, well, what's those pipes sticking out of the wall over there? And they're like, well, that's the sink. Well, that sink should have been over here. Well, now we got to move water lines. So just as an FYI. Sanitary waste and vent. So that's going to be any of your drains coming from your sinks. These are your drains. That's the biggest thing. DWV is your drain waste vent system. So in order for a plumbing system to work correctly, it has to be vented. A toilet won't flush right. A sink won't drain right if it's not vented. That has to do with physics. It lets the air out and allows the water to flow. But everything's gravity fed. So that's why your plumbers will typically always go first when you're doing the underground, and they will typically always go first when you're doing your above ground. It will kind of be a marriage between the HVAC, because again, like we talked about, sometimes you've got some tight spaces and that duct can only go through that hole that you planned on putting it through. So the worst thing that can happen is that like an electrician get loose. So that's a good example actually. So if the superintendent lets an electrician get in here first, and let's go to so we know that we've got ductwork running through here. Let's use this example here. So we know that we got a piece of ductwork that's running that way, right in here. Well, if that electrician gets in here and he starts, for whatever reason, starts running his conduit, and it's in the way, well, now somebody's going to be paying a change order. So, and that's going to be us. We're going to be paying the change order because the owner's not going to accept it. They're going to be like, y'all should have coordinated that better. And we should have. They're absolutely right. So we would have to pay the electrician to move his ductwork. That's why the handoff meetings and the pre-construction meetings, pre-install meetings for each trade are very, very important, because it will help identify who's going where and where they're running their stuff. All right. So vent pipes prevent siphoning of the traps. And then minimum slope. So that just talks about your minimum slope for your pipes, 1/4 inch per foot for 3 inch and smaller. And then PM red flags. So slope verification, that's typically more of a superintendent type deal. That's just verifying that your drains are sloping the correct amount. Clean outs, we really don't have a huge problem with sub plumbers not putting enough slope on their drains, because at the end of the day, if something's not sloped enough, it's on them. But it's just something that we need to watch out for. Clean outs are a big deal. Remember we talked about clean outs, or like at the car washes, it was in the pay station lane 1. We had a couple of clean outs there. And the whole purpose of a clean out, whether it's a floor clean out or a wall clean out, is so that after everything's all closed up, if we have a clogged drain somewhere, they can go and access those clean outs to run stuff down the pipes. And then vent penetrations are, most of the time, your vents are through the roof. They're going to be through the roof. There are a few that are called sidewall penetrations, and that's where we come up and we exit out the side of a building if it doesn't make sense. But most people don't like to do that because they're ugly and you can see them. So we try to avoid those if at all possible.
Okay.
Storm drainage. Okay, so this is kind of like what we talked about in the civil. So it's separate from sanitary. It never cross connects, ever. Roof drains, area drains, and trench drains will all go into your stormwater system. You do not necessarily have roof drains. So a roof drain is basically a downspout, right? Like on a house. It takes that rainwater from the roof, and it goes from the roof and your shingles, goes to the gutter, and then flows down the downspout. And like in all of our houses, it flows out into the street, and it goes into the street system. Some of these places are going to have roof drains, which means, and so that means, like we talked about when we did the roof, it's actually a separate hub drain that's up top, but that's actually can go and tie into the storm system. So if we look at West Bridgewater, we actually have roof drains that are going to be tying into the storm system. Let's go to our civil. Going to be very, very tough to see because he put entirely too much shit on these drawings.
Yeah.
But all right, I don't see one there. But so here is your roof drains. This is run underground, and you can see where, well, actually we've got an RFI in. I think they're roof drains because I think each one of these is hitting a downspout. So then this runs all the way down here, and you can see it turn right here. And then it goes this way, and then it ties back into our storm system, which is right here. So we got a manhole here, and then we've got so it flies off there. So we're essentially, that downspout will come down and it will tie into that drain. We actually had this at Billings.
Okay.
Billings and maybe Missoula. I don't remember. So you'll see, so residentially, you'll see stuff like, so that's what it should be. Not necessarily run into this, but it should be something similar to this, not necessarily with that on it. That's so if it gets clogged up, it's basically like similar to a clean out. But that's what you would see. Well, you wouldn't see that type of downspout, but that's essentially what it is.
Yeah.
And then it pipes into that and then goes to the storm drain system. So.
Okay. I'm going to start doing laps around my house in my parents' house. I'm just going to start walking around.
There you go.
Doing some laps. Same at Caroline's.
Perfect. All right, connects to detention and municipal storm. Floor drains need trap primers in dry areas. Um, this is also for the sanitary. Your sanitary is going to have trap primer. So this is something I didn't learn until about later. So a drain. So think about a waste drain. Let's talk about waste. Um, so a trap primer is, so when a drain is primed, that means it keeps water in that P trap. All right. So if we go to, so if you think about it underneath your sink, you've got something that looks like this.
Mm-hmm.
All right. So the reason this P trap is there, one of the reasons, is that it'll hold water. Okay. That acts as your trap primer. So what you're doing is you're trapping the sewer gas to where it doesn't come up through the sink and doesn't stink. That's why your sinks don't. That's why your sinks don't stink. Or if they do, you know you got a problem.
Mm-hmm.
So the reason they say dry drains is because if a drain is not used for a long time, so you think about maybe in a, not necessarily in a kitchen, but maybe it's a drain in a bathroom, like a floor drain that's in the middle of the bathroom. Sometimes those will get, sometimes those won't be used for a long time, and the water will actually evaporate out of here, and then it'll start smelling. So
Okay.
so you can always real easily to test that, you throw some water down the hole. That's it. And if it
Okay.
stops stinking, you know that that's the problem. So what they'll do is they put on what's called a trap primer. And this trap primer does exactly what you think it would do. It will always allow that drain to have water in it. See, so here's the, but again, this would be a good spot for like an access panel. So if this were in a wall, you need to be able to access this somehow. So you would actually have an access panel around it. But it will actually release water into this dry drain so that it always keeps water in the P trap.
Okay.
That's a good example right there. So that's an access panel with the trap primer inside of it. This is obviously going to some kind of manifold or something, but that's what you would be looking for. And then that would be on the
Okay.
wall with a nice cover on it, all that kind of good stuff. But yeah, that is a trap primer. So trap primers, storm sanitary separation and detention. Typically, you don't have to worry about the storm and the sanitary being separated. I haven't had that issue in a long, long, long time. And then detention connections. Not exactly sure what they're talking about there. I get all kinds of responses here. Yeah, I'm not exactly sure what they mean by detention connections. The only thing I will say is that, we had that problem in Salina where they put the water pipe was run real close to the dumpster enclosure.
Hmm.
And we actually had water, worst feeling in the world, by the way, whenever you get a phone call and you're like, you got a finished parking lot and everything, and you're like, we got water puddling up, or we got water coming up between our joints and our concrete. And you're like, but we had a water line that was not, they didn't glue it very well. They didn't primer it. And so when they put the pipe together, once it got under pressure, it burst. So, or just came apart. It'll just separate. So just with any connection at all, obviously that's more on the superintendent, to make sure that the connections are good. But you can also do the same thing. Like when you are, so like if you're walking a job and you see some plumbing, and you feel free to take like this drain line right here and shake it. Just move it. See if it moves. See if it moves on you, because it should not move. They should have these braces in there. Um, that's a good example, like right here. So they had to notch the stud, and they put that over there. But they should also have some. It should be tied off basically because it keeps
Okay.
that not necessarily a vent line because a vent line just moving air, but a drain or a water line or anything. These are PEX, so it's not that big of a deal. But they will actually move. They'll move under the vibration.
Okay. Well, and I think I remember there was an issue in Salina, and anyways, honestly, it just goes back to show the importance of the daily logs and taking the photos because it was post-construction. We had been operating for nearly 6 months, and there was another big leak by the pay stations, and it started in the bathroom, pay stations, all these things, and so I had to go back through on Autodesk and look at the before any concrete was poured, look at all the connections. And so, anyways, I know that that's one of the important things when it comes to plumbing and really anything on the job is just the constant photos of everything because you'll have to refer back to it a
Yep.
lot.
And,
So,
and don't be afraid. Like if you're looking at a daily report and you only see a couple of photos, I mean, coach the superintendent on photos that you need to see. I do to this day on everyone, like, cause they're on the job in their defense, they're on the job every day. So they're taking a picture of something that they've seen 1,000 times, but depending on where they took the photo, it's really tough to tell what you're even looking at.
mhm.
Depending, you don't know where you are on the job. You can't tell where because they took it too close or whatever. There's no frame of reference. But yeah, you can never have too many photos, in my opinion. So, um, all right. Gas distribution. So talking about gas. Um, yeah, this probably isn't more than one slide. Shouldn't be. Not that big of a deal. So gas is obviously run from your local gas or natural gas, LP. Um, well, LP is a little bit different, I guess. LP is so you've got propane and then you've got natural gas. So your natural gas is going to come from your city. If you've got propane, which you will on Dalton, you're going to have a
Okay.
big propane tank in the back. That is instead of them having natural gas, they actually provide their own propane tank. So that'll have to be something that's piped on the inside. So typically, what we'll do for gas lines is we put in a sleeve. We'll put in a sleeve, and then that way the gas line can be run after we're done with everything. But that basically gets us out of the ground. All right. Let's see here. Pressure testing, sizing, all of this information is typically taken care of your submittals. So
Okay.
the biggest thing that I can say on gas is make sure the gas company gets involved early, just like electrical. We want the gas company involved early. And then because they're going to want to know how many BTUs in order to size the meter. So that's how gas is measured. Gas is measured in BTUs. So you can take your HVAC schedule, you can take your plumbing schedule and see what exactly is being run by gas, if anything. And then it should tell you how many BTUs that's pulling. So then you can tell the energy company that, okay, we're going to have this much. We need this amount of pressure on for the gas meter. That's the most important thing to remember. Okay.
Okay.
That, and anytime anybody smells gas, we shut the job down.
Hmm.
So, um, all right. Any questions on plumbing? And we literally went through just a hot. Actually, we probably should have went through more slides. I'm not sure if they're going to talk about it when we get to the fixture. Like we didn't talk about fixtures or anything, but
Hmm.
not that there's a lot to talk about. A sink, a commode, a urinal. I mean,
Yeah.
it's plumbing's kind of is what it is.
Hmm.
Um,
Not too many questions, I guess, on plumbing, but I guess in regards of gas, I just had a question.
mhm.
Um, well, I guess for Dalton, do you know, just as I'm catching up to speed, do you know if the gas company has already been involved
Yeah,
or
they're not going to have gas there. They're going to
or
provide
the
their own.
propane?
They're going to do their own propane. So liquid energy, bite my tongue. Lipton Energy will actually provide. That's part of their company is
Okay.
they supply propane
Oh,
to residents. That's what Lipton Energy is. They have so they'll come out and they'll set a big propane tank. Um, Not sure if it's even probably not shown on our drawings. would be my
So
guess.
then with the difference of gas and propane, um, for propane, would you need to contact the gas company or no?
Mm-mm.
Okay.
Nope, because the propane doesn't tie to any kind of city utility at all.
Okay.
It just sits there. They'll come once a month or whatever, once every couple of months, once a quarter, however often they need to, and they will actually fill up that propane tank.
Okay.
Um,
Interesting. I've never heard of propane, like being
really?
on a job site.
Propane.
Mhm.
It's not common. It's not very common at all. Propane. So obviously, I mean, they have the, you got the smaller ones, right?
Yeah,
That we
I've
see
seen
outside
those.
Walmart or whatever.
Yeah.
Um, but that would be something like that.
Oh, okay. I've seen that, but I guess I never really,
Yep.
maybe I didn't have a mind that thought about it like that.
So they'll take that.
Mhm.
They'll set probably one. I think at the car wash we've got two, but I think they'll set one and then they'll run line like we'll run sleeves and then they'll come in and run the lines inside the building, and then from inside the building that's where the plumber will take it and tie onto his gas lines.
Okay.
So that's just something that's got to be coordinated as far as location,
Hmm.
because we're going to need to know where to run the sleeve. And like, there's not a ton of places to put it here. We're obviously not going to take up the parking places and we can't take up the drives. So I'm probably pretty sure that it's going to set um, somewhere over here,
Okay.
or maybe over here. TO7. Oh, this is the landscape plan. That still doesn't help me. Okay. I think it's going to set over here behind the curb somewhere.
Hmm.
So
Okay.
in a situation like that, if we want to run the sleeve, we don't necessarily need to know exactly where it's going to be. We just like for it to be close. So what we would do is we would just have the owner out and say, okay, where do y'all want to put, we got the dumpster here. Where do y'all want to put the propane tank? Well, let's pour a little pad and let's put it like right here. Okay, fine. So we just have to get that sleeve outside the curb. And then when it comes time to actually set the propane tank, that's when, if we need to run the sleeve a little further, if we need to change directions, whatever, we can do it. But it's just got to be outside the curb. So,
Okay. And on that, so on the photo that you shared on Google, it didn't look like they had a housekeeping pad. They just had kind of the gravel. Maybe they just have it for the stands. Is that how you would normally do it for a propane tank or a
uh,
pad like that?
I would pour a pad like this
Okay.
because it provides a much better, cleaner look, and you know that you're never going to have a problem.
Hmm.
Like something like this, where it's just done with like CMU block, eh. If we're doing it in somebody's farm, yeah, that's great. But I would actually put a housekeeping pad there. So it
Okay.
keeps it off, keeps it clear. You know, I would definitely do something like that.
Okay.
Cool. All right, MEP coordination, submittals, and inspections. Okay. Let's see here. Let's see what they're talking about. MEP conflicts, duct versus pipe. Okay, so this is a lot to do with like we already talked about. So dealing with the, well, it did a shit job of lining these up, didn't it? Let's fix this real quick while we're in here. There we go. Okay, structural frame complete, dimensions confirmed, MEP subcontractors submit coordinated BIM. Okay, we're not going to do BIM on most of our jobs. In fact, any. I have not done BIM since, so BIM, let's look up and see what it actually stands for. Building Information Modeling. Okay, well, that makes sense. So essentially what this is a good idea of what a BIM looks like. So this is where somebody goes in and they take a CAD drawing and they draw literally where all the electrical is going, all the fire sprinkler, all the HVAC, in order to prevent these clashes that we talk
Okay.
about. I'm not sure if it is anymore, but it was super expensive to be
Okay.
able to do that. So typically, like you need it in like buildings like this, because once you get one floor figured out, typically you're able to kind of at least use that for the rest of them. But you're running a lot more lines, you're running a whole lot more stuff. On our stuff, we can pretty much look at it because our stuff is a lot smaller, at least what we're doing right now. And we can determine where everything needs to be run. So we don't necessarily need the BIM modeling, but that's what it is. Whenever somebody says BIM, that's what they're talking about. Um, so ours would be, instead of MEP subcontractors submit coordinated BIM 2D coordinated, that's a call, right? We're having a pre-install call with our electrician, with our HVAC, and with our plumber. And we're talking about our attic space, and we're talking about where we're running everything. And then you can certainly make markups, kind of like that's exactly what we did though for the HVAC. When we ran through the HVAC issues, we got on the phone and I did basically redneck BIM modeling, I guess is what you can call it. And that's how we actually came up with like some of this stuff that I was making these markups as we were going through it and as we were talking about it. Verify the duct sizes. So once we figured out, okay, this is what the engineer or this is what the architect actually called out. This is what I sent to the HVAC guy. And I was like, here we go. Need to verify that these are good. Since you're designing the system, we need to make sure that these are okay. And then this is where we talked about, of course, going through the duct or going through the trusses. But that's essentially the BIM type modeling we did just without the fancy software. So it is typically it's very, very expensive to do BIM. So hopefully with AI, it's not that expensive anymore, but we'll see. All right. So PM and GC review. Excuse me. PM and GC review for conflicts, ceiling heights, duct, pipe, and beam. So that's you're just reviewing all of that stuff with it's something to bring up in your meetings with your superintendent. Is making sure that, hey, have we looked at, when's our pre-install scheduled? Not that you need to be the one coordinating with the subs on when to schedule it, but you need to be pushing for it, right? And then you probably will be the one to schedule it because you'll be working with their office. So, but you're certainly responsible for pushing to actually have the meeting and make sure, because it will take care of so many problems. Conflicts resolved in writing before rough-in begins. That's part of doing markups. That's part of resolving all that. Rough-in installed per coordinated drawings. PM inspects before the ceiling. PM and super, obviously. But that's just that's something that you would certainly look at, making sure that, because it's real simple. Before you just have checklist, right? Before we close up a wall, is everything run correctly? So a real common problem, I'll give you a real world solution. So like in a room, doesn't matter where it is, what I'll typically do is I like to, when we're doing the rough in stage, after we've got everything roughed in, but before we cover up, I'll take the electrical drawing and I'll count the number of outlets that I've got in that room. And I'll count the number of data outlets that I've got in that room. And then I'll look at that room and I'm like, good, good, good. Nope, we're missing this one. We're missing an outlet over here, guys. And then if I do that too many times, then I'm having a conversation with my superintendent before I leave that says, hey, we need to do a better job of watching them rough this in and make sure that everything's there before we leave. Because that's something that will, although we're not going to cost us monetarily because it's on the drawings and the electrician's going to run it, but it's going to cost us time, right? Because now we got to mess with back charges, because if it's a finished wall, then we're going to have the drywall guy, we're going to have to cut a hole. He's going to have to patch a hole. We're going to have to paint the hole. We're going to have, it just goes, it snowballs,
the whole
right?
process.
So, yeah. But you do that for not only, I just use fixtures as an example, light switches. Make sure the light switches are in the same, in where they're called out, right? But also be cognizant of when you walk an area that we're walking it like we're the customer, because it's silly, right? We can tell them all day that, yeah, well, we installed it how you drew it. That's not being a very good partner for them. So, like, for instance, if you walked into, let's say, yeah, here we go. So let's say that this is a restroom and you walk in and you see the light switches are mounted outside. So they've got say they have the drawings. If we looked at the electrical drawings, they have this little symbol. They have this little symbol that's an S. Oh, shit. Hang on. Here we go. S with 2 lines through it. That's always a light switch. That tells you it's a light switch. But it's mounted on the outside of the door. Well, that's a problem. Right? For 2 reasons. One, anybody can walk through here and turn the lights out on whoever's inside the bathroom. Well, that's not good. But also, typically, these are going to be occupancy sensors. So you've got to look and see if that's an actual switch or if it's an occupancy sensor. That's something that's missed all the time too. I don't think we actually had the city. I don't think we actually missed it in San Antonio. I think it was drawn wrong. But they made us go and switch to occupancy sensors.
Okay.
But that has to do with the energy code, right? Because there are certain, obviously if it's a manual switch and you have to physically turn it off, somebody leaves there, it leaves the light on, energy's burning, right? Because the electricity's on. So an occupancy sensor is just a sensor that's on the wall. So it can tell movement, right? So it's either a sensor on the wall or it's a sensor in the ceiling. And they look like, I know we kind of get off sometimes, but there's just so much to cover.
Well, I know it's interesting. Would you ever, now that AI is so big and would you ever take the updated listing of codes and put it into AI with the plans and just say, can you confirm these plans are up to code?
1,000%. That's what I think we should do on every single project. For the very reason, like in Massachusetts, where they drew all the sanitary to be PVC, but it cannot be. It's against code, plumbing code, for it to be PVC. And Modern Wash's reply was, well, y'all should figure that out then. Sorry. But that's like what they're paid to do. They're paid to check the codes, So anyway, so this would be a sensor in the wall with a light switch so that you can manually turn it off and on as well. But it also has a sensor, and then these are the ceiling ones. That's what they look like in the ceiling. So, but no, I definitely think that we should absolutely do that, and at least be able to, that way, if it calls something out, then we can research it independently, make sure it's accurate, and then we can do an RFI. And if I haven't already said it, I'll say it now, but whenever you do that, whenever you use AI for this or never, ever, ever reference it in any email, never reference it in any RFI, because they immediately take offense to it. Well, AI said this, or Claude said this, well, who's Claude? He's a guy that works in our office.
Yeah.
So,
Give me Claude's email. Okay.
Yeah. So, but that's just FYI. So anyway, as we're walking the space, whether it's electrical, plumbing, whatever, we need to look for, like when we're in the rough in stage, we automatically know, I can tell, I don't have a plumbing drawing on this job, but I know that I've got a sink here. So I should have some lines coming out of the wall. I should have maybe a drain line coming out of the wall. Here, I should have a toilet drain that's here. So if I walk into this room and I've got a stub up that's over here, I got a problem. Something's happened. And if I'm not aware of it, then I need to, why didn't we RFI that? Oh, we did. Well, it's in the right place. No, it's not. And here's, obviously before I say any of that, I always double check my plans. I make sure that I'm 100% right. Even when I know I'm right, I always double check the plans. And then I'll say, how did we, what's our game plan here? Like, what are we doing? Did we have something I didn't know about? Was there some reason we couldn't put the toilet over there? Whatever. So. Okay, rough it installed per drawings. Yep. Above ceiling inspection, walk, documented, punch list issued. So, I'm not really sure what they mean by gate. I don't know what gate means in this scenario, but it's almost like they're talking about sequencing. I don't know. Anyway, so your above ceiling inspections are very important. Like if when we had like we cannot put ceiling tile. So if a superintendent is going for his ceiling inspection on a drop ceiling and he's already put in all the ceiling tile, they will fail him immediately.
Okay.
And they will fail him because they can't see.
Mm-hmm.
So typically what we'll do is we'll put in like every other ceiling tile. Or maybe if there's an area above the ceiling that has a little bit of, or quite a bit of work in it, maybe we'll leave like 3 or 4 out. But the ceiling tile is typically one of the last things that you will put in because you don't want the other trades going through and moving that ceiling tile because they always tear it up, always. And then that always ends up being a change order. And then, not me is the person that damaged it. So
Yeah.
you're never able to figure it out because nobody admits to it. So it always ends up being a gap. So.
Okay.
All right. Talking about mechanical submittals and inspection hold points. So we've talked about cut sheets. So this is going to be this is what your submittal drawing should be all part of. Now, if you've got an RTU, it's going to have all your electrical data on there for that. But that's what the electrical engineer was supposed to use in order to size the service for that unit. So pipe submittal data, seismic restraint calcs. So that's if we don't deal a whole lot with that because we don't do a ton of work out west. That's typically where your seismic earthquake type stuff will go on.
Okay.
And then TAB procedure, of course. So test and balance is, we do want to test and balance in Dalton because it is a conditioned space. We will not have test and balance. And so you won't, there's no way to test and balance a mini split. So it's got to be like traditional. So think about test and balance as like traditional duct work. Anything that's got traditional duct work and it's got several rooms that are closed in, we probably need to have a test and balance. And typically it's, $1,000, $1,200, very cheap.
Okay.
So, but that's something that we like to provide with our closeout documents. So,
okay.
So underground rough in before the concrete or before the backfill. That's a pretty important one. I want to make sure all your stuff is in the right place. So before we go to backfill that concrete, a lot of times some superintendents will just say, okay, plumbing rough in's done. And I can look at the photos and I can tell if we're missing a stub up, if we don't have a stub up, I'll never forget it. I walked a project with Ken Brown in Tyler, Texas on the Smitties. And first thing I saw was a 3-inch PVC pipe that was stubbed up right in the middle of our equipment door. None of the framing's up yet. So you have to know what your plans say. It's not there's not a framed doorway there, which would have made it super obvious, or at least I would have hoped it would have. But I knew, based on, okay, you walk in from the exit of the tunnel, you walk into the door that goes into the equipment room. I know there's a door there. There's a double door there. And there's a piece of pipe stubbed straight up. So what's this for? Oh, well, I'm sure that's one of our drains. Well, you're probably right. Probably not wrong about that. But there's a doorway here. Oh, there is? That's like a red flag, right? Our superintendent is not paying attention to the drawings. But when you're going through daily reports, that's kind of the stuff that you're looking for too. You're kind of looking to see if something looks weird. Don't be afraid. Sometimes it's an optical illusion, but I'd say 90% of the time I'm right about whatever I'm seeing in the photo. And I'm like, that doesn't look right. Something's not right there. And I won't necessarily make a job site visit, but maybe it's between job site visits, right? I try not to, and you probably won't have a problem with this. I have a problem with this, but I try not to make them feel stupid. I've tried to really work on that. Try not to ask the question condescendingly or anything like that. And more of just an inquisitive, but not a condescending, you know what I'm saying? Not a condescending inquisitive, but a legitimate, are we really looking at the plans? We need to make sure that we're absolutely looking at the plans. So, so above slab rough in, so before the slab pour, gas pressure test. So your plumber will put on I put on a valve that'll show. A lot of times, like when you walk, so that's how they'll test some of the drain lines or some of the vents, because that's the other thing. If a vent has a hole in it, it's going to stink. It's going to get into the wall. It's going to, that's the whole purpose of that vent, is to get out to open air. Um, but you'll, like when you walk in and you see water lines that don't have water in them yet, or you see drain lines or stuff like that, they'll either do a test. So they call it like a stack test. So they put a ball in it, and then they fill it full of water, and like they want it to sit. So let's go to plumbing, drain. Uh, let's take out the word stack. This is very common. It's super, super common. You'll see it all the time, and it's literally what it sounds like. I don't see a good photo though. Um,
I'm gonna run to the restroom really fast while you're looking for that.
Yeah, go ahead. Um, so the important thing to remember is that it's not a. So you'll put test balls. So you'll put test balls in all your other places that it could potentially drain to, and that's what these are. And then you would have I still haven't found a good picture, but you would essentially have a standpipe, and it's full of water. And then the inspector is going to want to see that still full of water when he comes back the next day, to make sure that you don't have a leak somewhere. Is solely what that's for.
Okay.
So
I might try to find a YouTube video on that.
Yeah, the reason that that was one of the reasons that David in Salina got in so much trouble is because he or the inspector was absolutely balls to the wall afterwards, because when we did our test, the plumber actually put a test ball in the line itself, and then filled it full of water. So it clearly wasn't going anywhere. But they basically faked the test is what they did. So
Okay.
Yeah, big deal. Doesn't happen very often. Hopefully it doesn't happen very often for them faking tests, but that was the first time it had happened in my career where they had actually done it. And the inspector only found out because he told him to cut the pipe. I guess he saw something that triggered him to, and when they cut the pipe, there was the test ball inside the pipe. So anyway.
Interesting.
Yeah.
I do not remember that happening.
Water pressure test, that's typically done. So fire protection, you're going to need to do. They'll actually make you do a test because the fire line in Texas has to have a certain PSI. So the fire department will actually do the test on a hydrant for you to tell you what the city's water supply is. But typically that's not a big deal. We're able to test. They're able to test the lines. Obviously, in a car wash, it's happened a couple of times where we were losing water pressure, and almost every time it was on the city side of the line. So, and then of course above ceiling inspection, then final MEP inspection before occupancy permit. So. Okay. Related specifically to car washes, I'm not sure how much value there's going to be here. So reclaim tanks are never fiberglass, number one. High pressure supply, 1.5 inch to 2 inch. So it's always 2 inch. The only time you have a 1 inch is for your irrigation
Okay.
on our buildings. Reclaim pump room, coordinate with electrical and drain, floor drains every 15 foot in the tunnel. Yeah, that's okay. This isn't necessarily going to be applicable. Okay, backflow preventer. So that is something that's pretty important. It has to be inspected annually. And
Yes.
so, right, so we do it the first time. The plumber has to
Mhm.
provide a backflow inspection as part of his that everything's working right, but then it's on the client to do it every time, every year after that. And the
The
city will
re
come to
yeah.
you and say, you hadn't done I need your report. So,
Yes. The reason I had that reaction is because I got a email on the Smitty side, and they'd been sending them to you, and they never, I guess, realized it was meant to send to me. So I did my 6-month check on your email to see if there was anything important, and sure enough, back in October, we were on our final notice of we need the backflow preventer test. So, anyways, that happened like just last week, and
yeah.
so yeah, I didn't know that, and now I do.
Yep,
It's good to know.
yep, absolutely. So, let's see, gas boiler and water heater, high BTU demand, gas sizing critical. We've talked about how to look at those. Um, so what you would look for, it should be on our, electrical. Here we go. It's MWO2, MO1. Well, shit, fire. That's not it. All those things missing mechanical pages. Wait, look, is this one? It's all electrical. There we go. So if we look here in our schedule right there,
Okay.
that's what you would look for to give the gas company.
Okay.
60,000 BTU, and those are for the gas-fired heaters. We had an electrical heater, so there is no BTU there. But yeah, so that would be actually, we would need it rated for 120, because that would be both of them combined. So you would add up whatever it is and do it together. Let's see, dryer arch, of course, your blower motors, large electrical load. Ventilation tunnel. So what I've started doing is, you know how when you reach out to a power company or a power provider, you always have to do the load sheet.
Hmm.
So what I've started doing is taking their load sheet and taking the electrical drawings and putting them into AI and asking AI to figure out the loads for me. So works much better than waiting on somebody to answer an RFI.
Hmm.
All right. Cool. All right, let's talk about, let's see, we're doing okay on time, MEP and cost drivers. So just some real quick things, equipment substitution, different dimensions, rerouting. That's what we talked about with, so if by the way, has Paragon responded at all to any of your stuff?
They did. They
Okay,
responded to one.
that's fine.
Hmm.
All right, as long as she's responding, but that's going to be one
Yeah.
thing that you just need to let Callie know. Hey, if there's any piece of equipment that's changed or changes, we
Hmm.
need to know that
Hmm.
because we need to check the electrical to make sure it doesn't change anything on the electrical side.
Okay.
Coordination conflict found after ceiling closed in. Yeah, that sucks. Gas line is undersized for the actual BTU. So that would typically be caused because they have changed pieces of equipment out again, and nobody let the power company know. Or excuse me, the gas company in this situation. Duct rerouted around uncoordinated beam or conduit. So that's where we talked about with the electrician running his conduits, and then they're right in the way of everybody else. Plumbing's at the wrong height depending on the fixtures. So if they plumbed, the most common thing I can think about here would be one, not necessarily height, but location. One, a toilet. Actually, that would be the next one. So plumbing height being the wrong. So if it was a gurnal and they didn't plumb the water high enough, then if they plumbed it down low, then that's obviously a problem. Underground plumbing redug. So that's anytime. So that's most commonly a floor drain, or a commode drain or something. And we've poured concrete, and now we got to chip out the concrete and we got to move the damn thing. And then TAB fails. So that's if you got, so your TAB, some reasons your TAB would fail would be not insulated properly. They didn't pookie your ductwork. They didn't pookie at all. They didn't, whatever. That's, you got a leak somewhere.
Hmm.
Is why your TAB would fail.
Okay.
All right, let's go through. This worked pretty good last time. Let's work through some of these. Let's see. So the mechanical sub wants to close the ceiling in zone B above the before the above ceiling inspection. Rough-in is complete. They say the inspector is too busy. So number one, that would never, like, no, we're not doing that. We want the inspector out just because they call in their own inspection. We still want, it's time for us superintendent to get involved and
Hmm.
reach out to the city. So expected response: do not allow ceiling closure. The above ceiling is required as a hold point. Schedule inspection before. Yeah, okay, that's a simple one. During rough-in review, you find that the AHU, which is air handling unit, selected by the mechanical sub is 6 inches taller than the approved submittal. Ductwork has already been run above it. So what would you do? During the rough-in review, you find that the AHU rough-in review, okay? So we're in the rough-in stage, selected by the, pretty simple, I think. So we're in the rough-in stage. Ductwork has already been run above it, so it can't be any taller. So I would find out why we can't install the current, why I would go back. Number one, I would say, well, shit, I approved a submittal that, is not correct. And the design team did too, apparently. But you would have to research this to say either we need the right unit, like why was the right unit not submitted, or you need to start exploring options to raise the ductwork. Um, but either way, it is like another, like they call it a hold point. So
Hmm.
stop installation. New equipment dimensions require recoordination. Issue RFI. Request updated submittal. Cost impact likely 5 to 15K for duct reroute. Depends. It totally depends. But that should be like, that should never happen in theory, because the mechanical, like, you're working with the same contractor. They either put the duct in at the wrong height. That's something else you can check. They put in the wrong size duct. Like we talked about it being either rectangular or square.
Hmm.
Is there something we can do to change that? So, number three, the plumber has installed all gas lines but has not performed the pressure test. He says he always does it at the end before the inspection. Again, we don't want to do anything without being tested before we cover up. So we have to make sure that gas is at the correct pressure. Same thing with the water. We can do a water pressure test too before we close up the lines on the inside of the building. So TAB report shows 2 supply registers delivering 60% of the design CFN. The mechanical sub says it's close enough to the building and the building is nearly done. Too bad. That's not going to fly. We need to figure out why. So oftentimes that's going to be because we have an air leak somewhere. That it's not pumping or you're pumping too much air into somewhere else. Could be the other solution, but that's where you get your mechanical engineer on, or excuse me, your mechanical subcontractor on the phone, and y'all get it figured out with an on-site meeting most of the time. And then a coordination conflict is found between the 24 by 12 supply duct and a 4-inch sanitary waste line at the same elevation in the ceiling corridor. Ceiling height is already tight. All right, so hopefully we have found this before anybody did any work. But you're going to have to submit an RFI, and then that would go to your design team and basically spelling out the situation and go ahead and propose a solution. So before you send the RFI in, whenever you're notified about it, so a lot of times this may come up in a subcontractor meeting. That's the most real world situation I can say, is that your superintendent's going through the week look ahead, and then your plumber pipes up and he says, hey, have we figured out what we're going to do with that sanitary line? And you're like, what sanitary line? Oh, well, I talked to JJ about that 2 days ago. Da 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 da. And then JJ pipes up, yeah, well, I was working through this, not to pick on JJ, but I was working through this, I was working through that, da da da. And you're like, okay, let's table this, let's do it after the call. But yeah, so then your very next order of business then is to drop whatever you're doing and let's figure this out. Mm-hmm. So you would ask them, so, okay, we're going to submit an RFI because we're going to have a deviation from the plans, but what can we do? Like, get the HVAC guy on the phone, y'all talk through it, figure out, okay, we can run this line over here, and y'all change your duct to maybe 20 by 16 instead of 24 by 12. Same airflow, but maybe it works the same. So that's essentially what you would do. And then get it in writing from the RFI, and then you've got your direction. Hopefully no cost impact. Because hopefully we realized it during our pre-installation meeting or something else. But a lot of times you're not going to catch everything. It's not going to happen till the guys in the field go to put something in, and then they call their office and they're like, hey, this isn't going to work. This isn't going to fly. We've got this and that in the way. And then it escalates from there. So,
okay.
All right. And then, of course, some resources, plumbing HVAC standards. I wouldn't spend just a ton of time on this. Your YouTube videos will provide you with far more information, probably. Explain the HVAC system types, walk through a plumbing scenario. So as we go through, and it'll be a good education when we're roughed in Dalton. It'll be a real good education because you'll also get to, because we have walk-in freezers and coolers, you'll also get to see the evaporator coils and all that kind of good stuff that go on those, and actually how that stuff is piped. So that'll be a good experience.
Mm-hmm. So. Yeah, I'm looking forward to seeing all of that, because going through this, I feel like I say it at the end of every single video or every single meeting. It's I'm learning it and I'm understanding it, but I don't think it will come full circle when I'm actually in front of it. But
yeah, you'll have the light bulb moment. It'll go off without a problem.
Hopefully.
So. Oh, you will. And it'll happen at the weirdest times, and you won't necessarily know what you saw it from, or because you've consumed so much content or whatever else, but you'll know, just say, oh, okay, that's what that actually looks like. Mm-hmm. I know what to look like next time, or look for next time. So
yeah.
Cool. All right. Any questions or anything?
Not really any questions, but I was playing around right before this with Notebook LM, regarding the Dalton schedule, just kind of a podcast of construction scheduling sequences. And so as we were going through this, I was just thinking that may be something I could do ahead of time, is put these PowerPoints or put in some of the notebook questions into Notebook LM, and not necessarily in place of YouTube videos, but another resource.
Sure.
So I might do that with this one and maybe the next week. And then if I feel like it's working well, I can go back and do it for the other ones also.
Sure.
But just something, if they do work well for maybe the next PM that you mentor, that would be another good resource for this, because I was listening to it and I put in how to build a car wash, since I would know somewhat of the process, and it was pretty neat. And so maybe having it be prepping that for our meetings
Sure.
would be helpful. But
I think it's a great idea. Yeah, Notebook LM is a very powerful tool. I think it'll be awesome.
yeah, that was the first time that I actually played around with it and was listening to it, and I was like, wow, I kind of want to do some things about my personal life, like a skincare routine, like
There you go. Yeah.
something just random, because I was like, I would sit and listen to this podcast because it just sounds like a podcast, not, anything like that. So I was like, this would be really beneficial, because the other day I was going to turn on some TV just to brain rot. And I was like, no, I'm going to watch YouTube videos on construction. And so, but it's really neat. I will say, Caroline and I will be driving and she'll be like, so is that civil? What is that? What is that? And I was like,
Right.
well, tell me what that fence is. She was guessing. I was like, wrong, silt fence. So anyways, it's just fun, like watching this and learning, I'll walk around. Like I have a heating closet or a utility closet in my apartment. And so after this, I'm gonna go look, see what all that I have. But no, it's interesting how I have seen a propane tank that size before, but I
Sure.
never looked at that as, oh, that's a propane tank. I just kind of glazed over it. So it's
Right.
interesting watching how my mind shifts to more of a construction mindset.
It will. It will.
Mhm.
And once you get the sequencing down, that'll be the most important part.
Yeah.
But once you get the sequencing down on kind of how everything flows, that's when all the other little holes start filling in too. So
Yeah.
it'll be really, really awesome. So hopefully I think we're going to have a call tomorrow about White House,
Okay.
about the beach club. So maybe they're going to be good enough to us well, they'll give it to us if I lower my number enough, I'm sure, but I really don't
Yeah.
want us to do it for free.
Yeah.
So we'll see. But so I am going to Kentucky tomorrow. Do
Okay.
you have any time like tomorrow at 10 a.m. to kind of go through that schedule?
Yeah, I am this week I am free. I don't have a single thing. I think tomorrow I have an appointment in the afternoon, um, 1 o'clock, but other than that, I'm all set for
Let's go.
anything.
Yeah, let's go ahead and set a calendar invite and send me a calendar invite for tomorrow from 10 to 11. And
Okay.
we'll kind of touch base on the schedule. I got the internet figured out, by the way. So
Okay.
that's no longer an issue. I'm not sure if it's going to be I don't think it's been a problem. Well, have you done any Teams meetings from your desktop?
Um, so yes, the only thing about that is I don't have a camera or microphone set
You do
up.
now.
So they
I got you
they've
one.
been okay, they've been working fine. That's the only thing, is if I
Okay.
were to talk back, I can't.
All right.
But
So, but
yeah.
well, if we have an issue, I've got a fix for it. So
Okay.
on how we can do it and actually speed it up really, really fast. But anyway, and let's talk about the schedule, and then you can give me an update on where we are with Dalton, because we're looking at about 2 weeks before we're remobilizing.
Hmm. Hmm.
So you can kind of fill me in on where we are submittal wise, all that kind of good stuff,
Okay.
and the rest of the buyout and all that. So okay, no,
Okay, perfect. Because I had some questions. Ron submitted all of
okay,
his submittals
perfect.
this weekend, and I was going through it this morning, and so I'll get all my questions together today to run through that with you tomorrow. And then also, I'm planning on coming to town this Saturday,
Oh,
for that it's this
yeah,
Saturday, the AI
yeah.
thing.
It's
Okay,
I think I've got my schedule actually for, there we go. Yeah, it's
gotcha.
this
Okay.
catch up on AI, da 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 da. Yeah. So cool. Awesome. Yeah,
Okay,
I hope
perfect.
we get it. We may watch that for an hour and be like, this is
Yeah.
bullshit. And, but it could be something that's really good. I don't really know. So we'll see.
Hmm.
But
Okay, perfect. Yep. I
awesome.
plan on being there, and depending on the time I get in Friday, I'm going to try to use that weekend as prepping my office space. So I'll probably a
Okay.
printer and some storage. So anyways, I'll be doing that too. But anyways,
Got it.
okay.
And you've got a key, right? I
I
did
do.
get you a key.
Yes.
Okay, good. Good.
Yep. I
Okay.
do have one of those.
All right, perfect. Sounds great.
Okay. Alrighty. Well, I will
Uh,
talk to you tomorrow then,
all right, sounds
if not
good.
today.
All
Okay.
righty. Bye-bye.
All right. Bye.